Today topic is about diagrammatic presentation in the business statistics, transforming data into visual insights. In the previous class, we talked about how do we organize the data, especially classifying data, sorting data in the form of ascending order, descending order, and uh, how we what are the techniques we use to organize data like telemarking, frequency distribution table, and stem and leaf plot. And also we have discussed what are the advantages and disadvantages of presenting data in table form and graphical form. In the last class, we talked about the table presentation, presenting the data in the form of table. Today we will focus on presenting data in a diagrammatic format. So it's a diagrammatic presentation in business statistics. So this is the raw data. This is raw unorganized data. So here we have unorganized data. This area is unorganized data. We can organize the data in the form of table. It has rows and columns. That is option number 1. This is option number 2. It's mean a graphical representation. There are different chart or different graphs we can see. So this is coming under chart. This is kind of graph, and so there are a lot of different techniques, and there are a lot of charts and graphs available to presenting data to get more insight. So the purpose is to get visual insight. That's the purpose of using this kind of diagrammatic presentation. Why visualize data? So here, the raw data is in the form like this, or we can present the data in the form of table. But everybody, the audience, each and every audience, unique. Each and every audience, they are having the different expertise level, and they have used the data for different purpose. Um, Here, why do we visualize the data? A diagrammatic presentation is not just about the aesthetics. It's not for the purpose of beauty. It's a strategic tool to make data instant, comparable, and actionable. When you look at the raw data, here the data is given, data is presented, but this is very high. It is very hard to uh, recognize any patterns, any relationship among the data series, and so on. And also, it takes a lot of time to get more insights. What are the meaning? Are there any hidden patterns inside the data? For that, we convert this data set in form like this. Here we have two series, say here A series and B series, the data. We here y-axis and x-axis. In the y-axis, we can plot one variable, and x-axis we put another variable. And here we can observe, so B, so what the B, growth trend. So when we look at the data points, right, it's a time, for example, X series could be the time, and it's a income of B over the time is gross of the time. And the pattern of A, like the baseline trend, it's not grow much. It's like baseline. It looks fat. Look flat. So it's easy when we present the data. It's easy to recognize any patterns and the differences. It's easy to compare. So that's a purpose, right? It's instant and comparable and actionable. Based on by looking at this chart, we can get some of the insights. We can get some of actions, whether what type of individuals we are here to target, customers we are here to target, what type of income tax policies, so on. The first, it has visual impact, right? Visual, you can see Users grasp complex relationship faster than reading tables. If the data is presented like this, it's very hard, right? It's very hard to get the complex relationship. But when you look at here, it's very easy to grab. Comparison. In the row form and the table form, it's very hard and harder than hard for no, it's very hard for comparison. And here it's very easy for comparison. Universal. It bridges the gap between raw numbers and strategic understanding. Everybody unable to get in-depth meaning of the data set. When they use the table graph, not table graphs and advanced visualized techniques, so it's very easy. It's easier for everyone. So it's bridges the gap for the complexity into simplicity. The the chart, that's the power of chart. But here, very important, in there are a lot of charts available in statistics and visualization. But our focus is limited. Our scope is limited to pie charts, line chart, column and bar charts. Right? These are the basic charts. If you have a clear understanding of how these charts are working, how we create, how we draw this kind of charts, and you may uh, get clear idea on this, and you can apply the same idea into different complex tasks and complex charts. First one, we will talk about the pie chart, the basic form of pie chart. This is the pie, it's a pie chart showing the parts of the whole, right? If we have a data set, it divide whole data set into proportions based on the angle. When used when dividing total, right, total into components to show proportions at a specific point in time. You collect the data, right? You collect the data, and you have to show the proportions, the percentage, the or the main area, the dominant variable among these data sets, the variable. For example, in Sri Lanka, we have four religions like Buddhism, and Hinduism, Islam, and Christianity. Here, we can look, we say, right, 70, right, 70, 12, 10, 8, like that we can put. But when we present this data like this, so most of the larger portion, a smaller portion, right? When we present the data in this form, it's very easy to understand it. Here, one example is given. Um, Here, a municipal council has collected data on garbage disposal for a particular month. They categorized the garbages in four categories. The paper, they have collected 4 kilograms of paper and 2,500 kilograms of organic waste and 2,000 kilograms of plastics and 1,500 kilograms of metal. Altogether, they have collected 10,000 kilograms of waste. Total waste, 10,000 kilograms. Now, based on this data, we have to prepare a pie chart like this. How do we draw this pie chart? The basic idea is the total angle, right, of a round is equal 360 degree. 360 degree. And we have to divide this 360 degree into different portions, right? For example, paper will represent one portion, the here, 40%, right? So how we decide this angle? And the metal, glass, it's represent 15%. Then how we decide, like plastic, how we decide this one, and how do we decide this organic. So there's an angle, right? When we correctly calculate the angle, and then it's easy for us to draw this kind of charts. We found here paper, the corresponding angle 144, and organic 90. This one organic 90%, and plastic 72%, and metal and glass 54%. When you sorry, 54%, 54 degree, right? 90 degree, 72 degree, and 344 degree. So we have to divide this 360 degree into 4 different parts based on their value, kilograms. So how do we do this? Here we have total 10,000 kilograms, out of which the portion of the paper is 4,000. 4,000 into 360. Normally what we do to calculate the percentage, what we do normally, we use this formula into 100. Right? Then we will get the percentage. It's equal to 40%. Right? It is in terms of percentage, but when we want to convert them into the angle for the purpose of drawing pie chart, we have to place 360 instead of 100. Then we will get 144. Then take the instrument and write a point, and you decide what the radiant. So starting point is here, right? And you take 144 degree, and then draw the next line with the same radiant. And you draw this. This is 144. Next, organic, 4,000 or 10,000 total, and you take 2,500 into 360. It's equal to 90%. So take 90. This is 90%. So not 90%, 90 degree. And likewise, 2,000 over 10,000 over 2,000 into 360, and you will get 72, then 72, then draw. And finally, the rest is 54, right? Then you can place we can draw a perfect circle. So each represent the proportion. Then you have to put the labels, a paper, and it represent organic, it represent plastic, it represent metal. Likewise, you have to label them. If you wish, you can. You don't need to place. You don't want to indicate what's the degree, right? But in your working, you have to indicate how did you calculate the degree. And if you wish, you can put the percentage as well, right? Or you can put the count here in this example. So this is the pie chart we have drawn based on the formula. Here, right? Here we can put what is this? 4,000 kilograms. 4,000. Here you can put 2,500. Here you can 2,000. Here you can put 1,500. Or you can put the percentage 40, 40%, 25%, 20%, or 15% whatsoever, right? But the thing is that very important aspect of this drawing this pie chart is to determine their angle, right? The angle is very important. This is the formula to calculate their angle. Anything to ask? Is it clear? If you have any doubt, please unmute your mic and you can ask. Before that, please raise your hand. tracking changes over time. Now we look at the line chart. Line chart, how do we draw line chart? Best used to show the trend or growth or decline over the continuous period of time. You see, uh, you can see the diagrams like this. Oh, so here you can find the years 2000, 2021, 22, 23, 24, and this is GDP of country A, country B, country C, country D, country E, right? Like this. So by looking at these lines, you can compare the trend how each country's GDP behaves. So the country B is upward trend, and A is also upwards growing. But country C is flat, and country D, the GDP is fallen very fastly during the past 5 years. For this purpose, we mostly use uh, line chart. Here we take the example, the sales in terms of dollar by a product. So there are three products, A, B, C. And the year is given 1, 2, 3, 4, 5, 6. So 5, 6 years given. So normally in the line chart, we place the year in the x-axis, year in the x-axis, and the values in the y-axis. Now, when we draw, we have to decide what is the minimum number, what is the maximum number. Here, the range. We have to place all three product in one graph, one chart. So that we have to decide what is the highest value, highest and minimum value. Normally, it's better to start from 0 and the y-axis, right? The largest value is 54. So we can increment by 10, 20, 30, by 10 by 10, increase by 10, or we can increase 5, 5, 5, 5. The thing is, the gap should be unique, equal. First, take the variable A. In 2019, 10, we place the value here. Right? We place here. 2020, 12. 2021, here. 22, 14, and 16, and 18, and 8. Or use a different color and put A. Or you can use a uh, different line to differentiate A, B. If you don't have colors to differentiate each line, you can use different lines. The first line you can use this dotted line. The next line you can use like this, or you can use this for different, or you can use like this. Some people use like this. So there should be a unique pattern. And for placing B, right? So here 2019, take 2019, and NXX B. B is 28, right? 28. Then here. And 2020, right here, this column, and 26, point 25, 26, right? So likewise, we plot the numbers when we connect. Likewise, product C. By looking at these three lines, so it is obvious that this one, the C, product C, has the growth of sales of C, growth sales of product C increasing, and product A also increases, but very slowly increasing, and the product B, the sales, the sales of A is dropping continuously. So in the near future, it will lose their market. This kind of pattern, we can see. So otherwise we can take the decisions. Product B and A need a lot of advertisements concerning advertisement, or product B they have to restructure, or they have to investigate the market, the competition in the market. So this is how we can take some of the decision. Another form of chart, called the bar chart or column chart. Bar chart and column chart, the difference is the column chart, we draw it vertically like this. In the bar chart, we draw horizontally. That is a very different. This kind of bar chart and column chart prepared for the purpose of comparing categories. Comparing categories. Categories mean, category A, category B, category C, or X, Y, Z, or product A, B, C, like that, or country A, B, C, like that. Both chart use the length to represent value. See here, length mean for this column chart, we call the height. For each bars height. Each and everything has its own weight. Its weight, not weight. The height. Their height represent its value. Likewise, the length of this bar represent uh, its its value. Both charts are used length to represent value. The difference is direction and the readability, right? The direction here, column chart, vertical direction, and the column chart, the bar chart, it's a horizontal direction. This column chart is best for time period or short labels. Here in the column chart, we have very limited space to write the label name. But here we can write the name, the label very long. It has a lot of space to write. Likewise, it also has a lot of spaces. For that, when they are the labels are long, the names of the categories are long, we can use bar chart. Or it is short, or if you use the time in the Excel, we can use uh, column chart. The key rule here, height for column chart or length for bar chart represent value. For example, this is 40, this is 60, and this is 80 likewise. This is 58 something, and this is like 78 or something. Right, here we have an example, simple comparison. We use single variable. It's called simple column chart or simple bar chart. Here the column, the club membership count. There are 5 clubs: science club, sports club, drama club, music club, and ICT club. And count in the class, there are 45 students associated with 45 students associated with science club, 60 students associated with sports club, and drama 30, like that. So how we can present this data, this table in the column chart? Here we plot. We identify the maximum number 60. So at the top we need maximum 60. Maximum 60, and each increased by the 5, right? 5 times. So the base value maybe every 5. Oh, 5, right? So start from 0, maximum 60. First, science. Science 45. Here we label them 45, label them science, and here 45. This is 45 and 60 at the top. And the drama 30, right? And here 25. Very important, right? The width of each width of each column should be equal. There should be no differences, but you have to precisely locate what is the height. You simply take the signs, and here six labels. You put six labels, 1, 2, 3, 4, 5, 6 labels, and you have to put them correctly. And first you decide their height. If you decide here, if you put the dot signs, 45, the dot, and draw the basic line, and then you can connect this line as a column, it's a bar, right? And likewise, you put the maximum value here, 60, and draw a line, and then you connect these lines toward the x-axis. This is the mechanism of drawing column chart. Here, there are different techniques when presenting uh, the bar chart or column chart. So there are three categories. One is component. Here earlier we discussed this one. This chart having only one variable. What is the variable? The club and count. Only one. There is no categories within that. So it is called simple bar chart. Simple column chart. If we draw in this manner, this is called simple bar chart. Here, visualizing two variables. Here we have boys, girls. This is a total. We count the male and female in each class, grade 6, 7, 8, 9. Boys count in grade 6, 30, girls 25, total 55. Likewise, grade 9, 22 boys, 28 girls, and 50 total. How do we get total? Boys plus girls equal 50. Right. So we have to show the boys and girls in one chart. There are three ways: component, percentage, and group. First, we will look at the component. Right? Each class there are two components, boys and girls. You can decide either you can place boys first. After that, you can place girls. Boys, if you decide to place only boys, what you do is you draw simply the chart. This is called component chart, or sometimes called sketch chart, stacked chart. Let's see what the technique is. Here by looking at this, we have to first take the total, right? Boys plus girls, take the total and find the maximum value. 65 is the maximum value. So when you draw this, the y-axis represent number of students. You have to write very clearly, right? 65. This label is very important. And first we will work out here grades, how many classes? 1, 2, 3, 4 classes. So we put the spaces in accordingly. And first we will work out with boys. First count, how many count? Boys, you just draw. Yeah, I can draw like this. The number of students and the class, 6, 7, 8, 9. So first one, the boys. So here 10, 20, 30, 40, 50, 60. Here 60, how many girl? 30, right? So I put the point and I draw. Second, 28. 28 where? Yeah, almost here. 28 should be here, and I draw. And 28 here, 35, grade 8, 35, 35, 35 somewhere here, somewhere here. So use graph sheets. Use graph sheet so that you can draw a nice graph, and the width of each column should be equal. And grade 9, 22, grade 2 somewhere here. Right, you can. So this represent boys, represent boys. And then what you do is 25 girls in grade 6. Now you should know, right? Uh, 30 plus 25, it should be 55, right? So one way you can take 20, you take 25 units and take the value and row. Or otherwise, the shortcut is, the maximum boys plus girls total 55. So find the 55. Where is it? Somewhere here. Somewhere here. And like this. And so this count will be 25. And this count will be 30. Likewise here, grade 7, 32. Altogether 60 now. 28 plus 32, 60. So you can find the 60, the maximum value here. And then draw, connect this, and you draw separate pattern. Likewise, grade 8, 65. So, yeah, 65. So, sometime you may ask, right? So plus boys, girls, or sometimes cricket club, science club, ICT club, and total. So what happened this time? First, you have to draw for this. Second time, you have to draw for the science club. The third time, you can take the total. In this way, you can draw this. So it's very easy. This kind of chart is best for comparison. By looking at this, and by looking at it is easily compare each classes. So here, when you look at here, the grade 8 has a maximum number of the proportion, the height proportion of the females is high. And here, 32 the highest number of females in the class 7 portion. Right? So when we use this kind of component chart or stack chart? When we can use this chart when total is matter. Total is matters. Then we can use this chart. The second type of chart is called percentage chart, right? Percentage. Here, you know that altogether 100%. 100%. When you look at here, right, each bar, right, each column have different heights, the total column, right, different heights. But in the percentage has the same height, but the height of the subcomponent of the bar represent the proportion. Proportion means the parts. Proportion. Here, look at here. Focus on proportions. Focus on proportions. Percentage component or sometimes called percentage component chart. Percentage component chart. Here we know that how we draw this. First we have to convert. We have to convert these values into percentage. How do we calculate? How do we do that? Right. Here we have to convert these values into percentage. How do we convert? We know that what is the proportion of boys? Easiest formula is we know um, 30 plus 25 equal 55. Out of 55, 30 students are boys into 100. And out of 55, 25 students are female. Then we will get the percentage value. And here this is a percentage value. Here, what's the percentage? 54.5, right? 54.5 and 45.5. When you add the boys percentage and girls percentage, it should be equal to 100%. Everywhere it should be 100. Same formula we use here, 100. You see the proportion. In grade 6 class, proportion of boys 54.5%, while proportion of girls 45.5%. And grade 7, boys proportion is 46.7, the girls proportion 53.3, so equal to 100. Now, it's a ratio, right? It's a ratio. We have found this percentage based on the ratio. How? This way. In this way. This is the ratio, no? It's a ratio. Yeah, 30 over 55. 25 over 55 into 100. Likewise, 28 over 60 into 100. 32 over 60 into 100. So in this way, it's a ratio. We calculate it. Then we have table, no? We table. First, as we did earlier, always it should be maximum 100. You can't go beyond 100, more than 100. Right, grade 6. What's the proportion? 54.5. Right here, 54.5. Then put the mark, then draw the line. Draw line and you connect the line. There. Second, the balance, if we have two, no, only two. So the balance could be here. No need any calculation since we have only two variables. Second, 46.7. Grade 7, here 47.7, somewhere here. And we connect. And we put the point and put the line. I put the line and you connect. And balance up to the top. Right? Likewise, you split, you have to find a splitting point and you can connect at the top. For the bottom, for the boys and the top girls. It's better, it's good idea to write the percentage here as well. For example, grade 9, 44% male and 56% female. It's nice, it's look nice. So if we are not using the color, you have to separate. For example, for girls, you can put like this, you can, or for boys, you can put like this, or you can use this way, or you can use this. Right? So there should be a clear differences. So by looking at this graph, right, it's very nicely explain us what is the in which class proportion of girls is high. In which class proportion of girls is high. Proportion of the girls high. By looking at this picture, it's very easy to say that proportion of girls. And here, this is the largest area. And which class the girls is high. So we can look at here. By comparing this, we can say the proportion, not the count. Right? Not the count. Proportion. Right? Proportion. Here, highest proportion of girls despite here. Right? When you look at here, this explanation marking here, highest proportion of girls it represents, despite being smallest class. Here, smallest class, smallest class. Here, earlier, right, we already found here only 28 females, only 28 females in grade 9, but the proportion of the females are high in that class. So this kind of insights we unable to get from this kind of chart. It present only the count, not the proportion. And the total is important here. But here, the total or count is not important. The proportion of male and female is important. Yeah. So that is the power of this proportion component chart. Now we look at multiple or group chart, multiple or group chart. Earlier, you see those graphs are like this. So this is count meter, here proportion meter, but here it's a grouped male, female, male, female, grade 6 and grade 7. These two columns represent grade 6. These two columns represent grade 7. Likewise, here what we can do is, right here, grade 6. We don't want to convert into percentage. It's very easy, right? We work out on boys. Here, as usual, we are having the number of students here in the y-axis. Here, and in the x-axis, we have category. Right here, the boys 30. We put the point here and row for boys, and here we put the point and row connect. This is boys, this is girls. So if we have different color, we can use different color. Otherwise, we can use this kind of mark. Don't make it blank. Right. So we can draw for grade 6, 7, 8, 9 in the same way. So here it's very hard to find out the total. Destroys the total view, but makes the comparing. Now it is easy to compare which class is having highest high or lower with among the gender. Right? So when you look at the grade 6, we can compare. Females are less than the boys. In grade 7, females are higher than the boys. And grades 8, boys are higher. And grade 9, girls are high. So this kind of comparison. But it's very hard to find the total. So what we have to do, we have to do the manual things. To find the total, we have to take 28 plus 22 altogether 50. Right? So in that way, we have to find the total. But here, when you look at here, it's right, it's directly show the total. And it's also very hard which class is having the highest number of students, but also difficult to find here. So when the comparison is meta, the ultimate purpose of the diagram is to find out the comparison, male and female comparison. We can use this kind of things. When we use multi-group chart or component chart, the decision guide staked sometimes component, staked or grouped. Multiple or group chart. The purpose, the focus is individual component. Example, boys and girls. Individual. Here, this bar, this bar is decided to boys and this is that. So if you want to compare, these things, we can use multiple group chart. What is the advantage of having easy side-by-side comparison of specific values? We can compare boys and girls. The disadvantage, harder to see the total for each category. Right? To find out the total, we have to manually, we have to work out take the value of boys, take the value of girls, and we have to find the total. That's the thing. Rule, use compare A and B. So if you want to compare things like side by side comparison, we can use multiple group chart. A component, a stake chart, focus is to the part to whole relationship. It's mean the proportion. If you want to find out the proportion, component stake chart is fine. The advantage of this chart is shows the total clearly. And the disadvantage is to harder to compare the upper segment because of their baseline shift. Right? Upper segment here, when you look at here, the upper limit, yeah, the girls start from here. Girls, yeah, in this column, girls start count 0 here. Girls count start 0 here, 0 here. So it has different baseline. 0 starting point is different. But for boys, for the first group, all start from this x-axis, the base. That's a challenge. Analyzing complex trend and product sales. Here scenario, comparing product A, B, and C over last 3 years. So the product is given A, B, C, and the year 22, 23, 24. And product sales also is given to you. Product here, just we plot this data here. So it look like this. This category for product A, this category for product B, this category for product C. This represent 2022. This represent 2022, 3. This represent 2024. Likewise, this is 2022, 2023, 2024. Likewise, same. 21, 22, 23, 24. You have to maintain the order. And if you use the color, this color, you have to use the same color here and here. If you use this color for this 2022 and the same color or same pattern you have to use, so that it is very easy to compare. Right? Easy to compare. It's called multiple output. Right. The things what you have to remember, rules for professional presentation. Right. Number 1, always start from 0. Scale at 0. Value axis must start from 0 to avoid misleading exaggerations. Always origin should be 0. It's better, not always. Clear labels. Label X and Y. X. What is X? What is Y? It should be very clearly written. Label X and include units. Example, whether it's rupees or dollar or count, we have to clearly write the labels. Mandatory legend. Essential for multiple or stake chart to identify colors. Here you are using a different color. Either you have to write here, otherwise you have to very clearly differentiate like this, right? And consistency. Bars must have equal width and equal spacing. Here, in this graph, we have, all the width of the bars are equal, right? But here, and also at the same time, here the space, we maintain the same space. If we are not like to place spaces, we can draw like this, right, without space, but we consistently use the width and consistently use the color. Simplicity. Avoid clustering more than three variables side by side. So when you put a lot of bars, lot of categorization, it's very hard. So in that instances, we can use the type of charts. Right, test your understanding. So it's a quiz for you. We can do it later. And the summary, today we discussed pie chart for the purpose. So for one variable, right? For one variable, the proportions. Line chart, so we have many variables, different categories over the time. Over the time means the year, time, something like that. Simple chart, so only one for comparing items, only one variables, one category, not variables, category. Here also one category. And stack, right? One variable, two or more groups, subgroups, labels, categories. So it's stacked or grouped. No, sorry, not group, component. It's better for totals and comparison. We have two type of things here, percentage as well as total. So very important when you decide which type of graph you want to do. And grouped here, side by side comparison, comparing specific subgroups. A good chart answers a question without needing to read the raw data. So if you are presenting, if you are drawing a nice chart, no need to go for a raw data again.